Okay. So, where is use? I will go back to these slides. So, I believe you've heard about two main data structures, like data processing paradigms, FIFO and LIFO. So FIFO first in, first out, LIFO last in, first out. So this are examples of these ideas. So Q is the data structure corresponding to first in, first out. The first person in Q will be source first. The stack is the idea of last in, first out, like this pile of books. When you take the book from the top, it's actually the last book that you put on this file. So can you think about examples in computer, like in coding or in machine, when we use queue or when we use stack? So these are more examples. But these are not from computers. It's example of the first in, first out, or last in, last out. The pancake. Hmm? Is it stack or queue? Yes, you will eat the last pancake from the top. Yes. So first in, first out is queue. Accessed by key is dictionary. Last in, first out is stack. Access by just when we store just unique elements is set, and when we access by indexes, Python list. So can you think about examples of stack? And I mean, why actually we want to learn these data structures? Can you think about examples in PyCharm, on Python, in computer, for schedule processes, maybe? Oh, when we open PyCharm, do you remember, and run the debugger, what did you see on the left when we ran recursion? Do you remember, like recursive calls of the function? What was the name for that? Re execution, execution, stack. So actually, we use this terminology, and as you remember, it was the recursive function called the function, the instance of this function, and then it was running the last call of the function first. So this was example of the stack. So can you think about examples of queues? So for example, when you press the key on your computer or when you download some files, are there any queues?
Yeah, if you download a file, you download two files. There's a queue in which file
Yes.
first.
Yeah, so this is the example of queues, but also every process in your computer is placed into a queue, but it's not the normal queue, it's um, priority queue. Some operations have high priority. For example, if you want to interrupt your program, then Control X, for example, key hotkey will have high priority and it will run immediately. Okay, so just some ideas when we want to use queues and stacks, but also before we're going to the code. Oh, sorry, it's the code example for today will be actually the game. So we will have troll and goats, and also we will have a cavern. So first, goats will go inside this cavern, and when they will enter in this cavern, so the first goat will be like in the back of this cavern. And then they will go out from this cavern to fight the troll. So the last goat enter this cavern eventually will go first and die. I know it's something. I don't know what it's like, but it's funny. But um, so several votes will be assigned the like fight points randomly. So several votes and troll also will be assigned some fight hit points, but of course more than goals. Make it 10 times 4, so about 10 goals should die. And after they hopefully fight the troll, they will go to the bridge, the remaining goals. And there is another problem that bridge can also collapse under their weight. So if we will represent the cavern with stack, because the last goat entered the cavern, so will go first to fight. But the bridge, for bridge, we will use queue because the first goat which enters the bridge will first reach the middle. So this is the game that we will play today, but first we will write the data structures for these queues and stacks. Okay, let's do some coding. New project. Week 10. So to simulate these data structures, we will use nodes. So let's import from data classes import data class. And we will create a node, but we will use today frozen nodes. Frozen nodes will raise an error when you want to change the values inside this data structure. True. Class node. So node will have two parameters. So if we go back to our slides, we will represent the data, like, for example, stack. So first we'll create empty nodes, and each node will have two parameters, value and the pointer to the following node. So, for example, if we create one node, let's say node with value A, so let's say we have just one element in our stack, then the pointer or next will be none. But if we want to create a new node, let's say B, also maybe with none, then the node B actually should be on the top of our stack. So that's why the next value for node B will be actually node A. So it will be A, and the pointer of this node will be, the next of node A will be none. So this is how we will implement the idea of stack. Every new node will be kind of the main node, and the first node will be in the end of our stack. It's kind of nested nodes. So that's why we create this node data structure, and then we will use these nodes as just train cards. Like the first node, then we will add the next one, and so on. Okay, let's write the class of node. So it has two values, two parameters, value. And for now, let's indicate int, but I hope you remember that you can indicate arbitrary data type and assign to the value string, for example, it won't complain. Then next, a pointer to the next element. So it will have type of node or none. So let's create a node with value 0, for example, or I can use also string just to show that int doesn't mean anything. and pointer none for now, but again, it can be arbitrary. And I will run this in debugger mode. So in debugger mode, as you remember, all this code was interpreted until this breakpoint. So that's why if I want to print now this variable node, I should get an error. So I can create a node, initialize. So I can print it now. And the node has these two initialized parameters. And again, there was int, there is string, no problem. But if you want to like to be more precise, then you can import from type in import any or union, and then because you don't know in advance what will be the type of your values in this stack, you can use any data type. But again, it's just for user who will read this code, maybe makes sense. And union works as or, so here we could use union and list of possible types. Okay. Then we can create a node and as a next element. Oh, by the way, if I want to rewrite the value of my node, like value equals 0, I will get an error because we created frozen node. So you can create, like initialize your node, but you can't change the values inside after that. So, and finally, instead of this next element, we can create another node. So, I know, like 1 and none. And then we will have these nested nodes. So the value of the first node, the pointer to the next node. So the next node has value and the pointer to the next. And so, okay. So how you did you understand this idea of nodes? Now we will use these nodes to implement stack and queue. So um, the stack has three main operations. Push to insert a new element. Size will return you the number of elements in the stack, and it's easy when you push a new element, just increase the counter. So then check if it's empty or not. And pop. Pop will read the top element and remove this element from your stack. So also we will write function top that will read the first element without removing the first element. Just it will return the value of the top element. So we start with empty stack. So we will create a node stack. Oh, stack. It will have parameters size, which will be initialized by 0 first, and pointer to the top element, top. So when we create our empty stack, the pointer is none. When we add the first element, how to move it? Okay. So when we add the first element, the size will increase by 1, and the pointer will point to the first element. When we add the second element, the size will increase by 1, and the top will point to the second element. And the first element will be kind of nested in this second, like on here on the top B, and the next value will be A. When we add next element, for example, C, it will be in the field next of element B. Oh, no, sorry. C will be outside, and B will be in the next element of the C. Then we can do pop, and pop will reduce size and also remove the first element. So push again, as I said, it adds the new element on the top of your stack. So empty stack has size 0 and top points to the none. When we create a new value, a new node, um, uh, we will increase size by 1, and pointer next will point to our new node. So in image, we indicate this with an error, but in code, we will write stack.top equals this node. So then we add new node. We insert the previous node as next value to the new node, and which change also the pointer of the top to the the new node. So this is the idea of push. Pop, in pop, we will read this value. So it will be stack dot top dot value. And then how to remove this node, we'll just change this pointer stack dot top to stack dot top dot next. And next actually is the next element, the second element from the top. Okay, let's code this. Um, So we created node. Now we will create stack. Data class. But what do you think, guys? Should it be frozen or normal data class so we can change the values? Yes, and why? Size, for example.
Yeah.
Yes, correct. So we will create stack without frozen statement. So by default it's false. Stack. And we have two fields here, size um, and the top element. So top can be a node or none. Now let's write several functions. So first function will initialize our stack. So create or make. Let's do make empty stack. And this function will create the object of type stack. The first, because it's empty, size will be 0, and top element will point to none. So then we will write a function is empty that will check if our stack is empty or not. Because if it's empty, for example, we can't remove an element or like do pop empty of stack return. So it's empty if the pointer of top is none. Stack dot top is none. Next function, we have method stack dot size, but we will write a function size because if our stack is empty, it will raise an error, for example. Of course, we can also check if size is 0, but the other way is to check if stack is empty. We have this function is empty stack. Then we will raise the exception index error empty stack. Otherwise, and I'm not writing else because if we have exception, then our code actually stops working. Interpreter will just stop running our code. But if it's not empty, we will go to the next line, so there's no reason for else. I mean, I could use else, but it's the same. Size. So otherwise, we return stack.size. So what else? Push and pop and top. Three more functions. So define. So again, just to distinguish between attribute of our stack.top, and function, I will call this top function. So it will just read the value of the top element. Top function of stack. Again, we should check if it's not empty. So I will just copy paste this. So if it's empty, there is no top value. Otherwise, we return stack dot top dot value. Because as you remember, the stack has parameters size and top, but top actually contains the next node. This node, for example, if there was A, it will contain also A, and A doesn't point to nothing, so it will be none. So if I call stack.top, it actually gives me the node with B. And then I read the value of this node. Okay, then pop. In pop, we will read the first value, but also remove the top element. So pop, and because we don't have this attribute in stack, I can use just pop without pop func. Again, we check if it's not empty. If it's not empty, we will read the top element. Popped element is equal to these values. And after that, the pointer top, instead of let's see, instead of pointing to node B, should point to the nested node. And the value of the nested nested node actually was stored in the parameter next. So we change stack dot top to stack dot top dot next. Also, we should decrease our size by 1. I believe that's it. Should we check if our stack contains only one element, we remove? No, it's fine. The last element, the value of the last element is none, so top will point to none, so that's fine. And the last function, push, to add new element. Push. So first, in push, we also should indicate the second parameter, the value element. First, we create a new node, and the top will point to this node. So stack dot top will point to a new node. This node will have value element, but the parameter next will be the previous value of top. So stack dot top. And also by the way, in push, we should return the popped value, return the popped. And here in push, we increase counter the size by 1. Stack dot size increase by 1. Now let's run this code and see the output. So we create an empty stack. Oh, we have a function, make empty stack. Okay, so this is the initialization of our stack. Then we push a new element. Push. Oh, by the way, we can check stack.size, and it will be 0. But if we use our function, size function, we will get an error because the stack was empty. Okay, so let's add an element, push stack value first, and print. So it created this data stack of size 1, and pointer points to our inserted element, which is a node with value first and next none. If we insert one more, push stack second, the size will be 2, the value of top will be a node. This node will have value second, the latest, and pointer next will contain the previous node with parameters value first and pointer none. Okay, so do you want to make a break before queues, or we can go to queues? How do you feel? Okay, let's do 5-minute break and then we will. So I won't code queues. I will just copy paste code from course page and just will explain main. So it will be faster. And then we will use this data structure to play our game with goals. So let's do 5 minutes break. So it's 5:55. Continue.
I'm getting it. What do you think?
I'm still just. Why would you?
Wait, is this from the did?
It's not very red, but.
It's supposed to be pink. I just like so many things.
Oh, it's supposed to be.
No, I just thought it was like. It's right there. The second. Value of the. One of their friends is a little bit odd. Is it out of this? It is.
I mean, it would just be this and this. Plus, you like, students don't. So, this.
Oh. And then we might shoot that. We might need, I don't know. So. Yeah.
I mean,
wherever you think it's going to let's do something. Step over.
so if we do.
Yeah, it's what it possible. But
Step by step. I'll show you where that's, let's say.
and then you have well, when it's
I didn't know what to do. Can you remember?
Basically, the then,
But-
you gotta do all the critical value.
well, it depends on the assumptions.
Of this,
Because of course,
well, not even, no, it's finding the critical values of the.
what the calculate all the physical. facts and-
Yeah.
Yeah, exam.
No.
Oh, I got to know one
I would kind of hold it.
Yes.
I had mine.
Okay, I dropped very almost over.
So
I'm gonna pass it.
But it's a dog.
Yeah,
Yeah,
there's-
there's the open pages, all the path and where is
Oh my god.
Roger.
Looks like.
What's your thoughts on Tyler?
So,
I'm gone.
Yeah, out of time, what?
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 I need more time listening to.
yeah. Okay, so.
Oh, yeah, I agree.
You haven't finished yet?
No, you've not to listen to it completely 4 times, it's still probably like set in stone value to the great one.
Alright.
Give it a six just because this thing is sticky or whatever. That's a really bad one.
That's what I'm saying.
Got it.
Yeah. I give the love. We could get her. I got fucking endless bag of dreams up right here. So. Thank you for
Upper case, it understands that you're
Don't
blind.
know why.
I
always spend my day doing
Okay.
fucking candy.
Valid. Try
Frozen meals and candy.
to change like return,
There's nothing else to
but
buy.
because not, because here it's initialization.
Asian, but apples, the Wawa,
Yeah.
over here, and I'm kind
Yeah,
of
when
like,
they-
they got rid of this. No, we can providers all. Yes. I don't know. They give like free barbecue things.
Control.
Oh, yeah, it's not anything, yeah.
This headphones.
You saw what you
And there, so you.
I worked off my.
Wait, so what is static? It's not what is,
Oh,
what is lower house?
So, it's the equal of class. So class is the data type, but when you create a variable,
I thought.
I gotta go with
I
baby.
call this like lowercase, I call state equals to this uppercase.
Oh.
You create an object of this class.
Where is the?
In Maker. The uppercase. So
Yeah, like gloves, like, you know, when people get
this, that's,
they can't itch themselves.
Saying, what am I missing?
Yeah.
so,
Yeah.
so you can create like nodes, so you can create different objects of type node. You can create different objects of type.
Like, hold them calm.
And when you decide to use step over uppercase dot top,
This works.
it was thinking about
So we just strap her down, basically, like, is this turning
it's
into?
not about there.
Okay.
It's not about specific their node of this type.
This is what it comes out.
What did you pull that? No, I don't. I'll be okay. I'll be back. I'll be back. Oh,
Until this thing right now.
So in this case, it'd be kind of.
My mouse works.
Sorry, but in this case, it'd be difficult to have multiple stacks open at once, right?
Just stop.
Well,
Because
we have multiple nodes
File.
because when we create, when we do push, we create a new node. So we have multiple nodes, but we work with one stack. Yeah.
Okay.
I mean, you can open two stacks, but if you need.
okay, how would you do that? How would you open two stacks?
Oh.
Just you can, when you create stack, make empty stack, you can write stack one equals make empty stack.
Oh, oh,
Yeah.
yeah. Oh, okay, I got it now. Okay, thank you. I understand.
Okay, so I had a question during break about upper and lower case. So
And when you write it to the playlist.
so in the code, I used uppercase stack only twice. When we created class, you remember for classes we use camel style, and when we initialized our stack, everywhere else, I used a variable stack with a lowercase, and you could create. So, for example,
Now you do it again. Creation. You write it first day, and then you write that.
for example, we have this data class node, and you can create many instances of this class. For example, node 1 equals node with some parameters. You can create node 2 with I don't know, some other parameters. So when you create the data type, then you can create multiple instances of variables of this data type. Yep. Okay, so let's go to queues. Queue represents data structure 5 first in, first out. And we will have also specific for queue methods. To remove element from queue is called dequeue. To insert element will be called enqueue instead of pop or push. Then the other difference is that instead of one pointer, we will have 2 pointers. In queue, I will draw here. So when we create queue, structure, it will have size, but in contrast with stack, it will have 2 pointers on the first element and on the last element of the queue. So we will call this front and back. And when we will do enqueue insertion of an element, I will explain why actually 2 links are important to keep all operations in constant time. Front and back. So in queue, as you remember, the first element will be dequeued. So we will use front to read the first element of our queue. So we start with empty queue. Both pointers, front and back, will be nonce and size 0. When we enqueue or add the first element, both pointers will point to this element because it will be first and the last for our queue. But when we insert the next element, now the first will be front, but the next new element will be back, and so on. When we dequeue, the first element will be read first, and so the front, we will read from front until we reach the end of queue. So this is the initialization. We will write function make empty queue, size 0, both pointers nonce. Then we create the first element as a node, and indicators of front and back will point both to this node. So you can, if you remember lists, when you create a new variable, like a new list equals to the previous list, it creates only the link, the pointer to the computer memory. It doesn't create a new objects. So the same here, we write front equals this node, back equals this node, but they indicate to the same memory in your machine. Now, we want to add a new node, and this is the place where the back actually
Being your
will
right
play its important role.
No.
So the front will still point to the first element, but the back will point to the new inserted element. Let's think about two different situations. You can create the link. So let's first write a diagram. So, for example, we had element A, and we want to insert element B. As you remember, in stack, we inserted A as element next of B. In Q, our like top element or front should be A. So in Q, we will insert B inside A. Actually. None. So this is what this error, this link indicates. A next value will be B. And then our point of front, it won't change when we include new elements. The front always will point to the first input element, to A. But back, it was pointing to A, but now it will point to B. And now let's consider two different approaches to create this link from A to B first, and then to create. And the second approach will be to create the link from back to the new element. I will use a different color. So let's say I want to insert a new element C. And let's think about this situation. First, I will change this link back to this new element C. So if I first create this link, back will point to the new element. So how to insert this element into the next of element B? You will need to start with pointer front. Then you will need to read next until you reach none. and how many steps, time steps you will spend to find the last element of your queue. And the number of elements. So if you cut first the pointer to your last element, to find the previous last element, you will need to iterate through the entire queue. So that's why actually we kept this pointer back. So now we will do different way. So first, we will create a link from B to our new element C. So it will be first link. And this will be constant time because we have access to our last element by pointer back. And after that, we will change. And after that, we will change our pointer. So to pointer back. So it will be second step. In this case, the insertion operation will be done in constant time, just 2 operations. Instead of iterating for the entire view. So okay, so enqueuing is just tricky operation. In queues, dequeuing is straightforward. For dequeuing, we just read the value of our first element, and then we change pointer from the first to the queue dot front dot next, and that's it. Okay, let's upload now code from the course page. Так. Okay, I can erase this. New file. Queue. Oh, wait a second. I wanted queue, but I copied stack. Sorry about that. So they import these nodes like frozen nodes. I will just copy paste my node. And by the way, because in queue, we changed the because in queue we keep the first node every time, and we can change the pointer. Now it shouldn't be frozen. It will be just a normal data class. So you can write frozen false or just erase this. Okay, so queue. size, pointers front back, make empty queue, initialize size by 0, pointers by nonce. And queue, you remember, this is the most tricky part. First, we create a new node. Then, if our queue was empty, we just change the pointer front to this new node. Otherwise, first we um, um, so queue back. So first we change the pointer of the last element. So you remember I was drawing these diagrams and trying to explain that first we should insert the new node into last element and only then change the pointer to the back node. So this is actually where it's done. We use the link to the last element back and create the pointer next to the new node. And only after that, we change the pointer back of our queue and increase size by 1. Okay, the queue is simple operation. If our queue is not empty, we read the value of the front element, of the first element. And then we change the link to the front next. And decrease size by 1. And if our queue was contained only one element, then all the pointers we should set to none. Front just reads the front value. Back just reads the back value, and is empty checks if it's not if it's empty. So let's just write test create a queue, make empty queue. Okay, what's wrong? Oh, any is not. Oh, it's important only union. We should also import it. Okay, so it created the like empty queue, size 0, indicate pointers nonce. Let's insert one element. So it's called enqueue. First. So now our queue has size 1. The front points to the node with value first, and back points to the node with value first. So to the same nodes. Finally, let's enqueue the second value. Second. And now size of our queue is 2. Front pointer indicates to the node with value first, and pointer to the next node with value second. And back points to the node with value second only. Okay, now let's play a game. For this, we should copy. I will open the folder open in Explorer. And I should copy all the files from course page, called Billy Goats graph to my folder. Let's open this Billy. Okay, let's take a look at Cavern first. So Cavern is a stack. You remember? So we randomly generate some hit points for troll between 100 and 200, and some hit points for goats. So they are weaker, and so random hit points are between 0 and 100. Then we will, as you remember, if we have some survived goats, they will be stored in a stack. And like the last goats entered the cavern, they will first go to fight this troll. So until at least one goat survived, until our stack is not empty, and until troll is alive, we will pop our goats, pop goats from our stack. And depending on the hit points, they will take some points from troll, and most likely they will die because yes.
When they kill the troll, they still die.
Yes, they're safe.
Oh, do you mean if the number of hit points is equal, like?
No,
Huh?
if the number of hit points.
For example, you will see this in the example. For example, troll has. Do you mean when the number of hit points is greater than the lives, or?
When the hit point is less than the damage.
Which situation do you mean? So we will have situation when the number of hit points, for example, troll hits the goat with 500 points, but the life of goat is 200. So then goat will maybe hit with some hit points troll, but will be dead. But if the number of points is smaller, then let's say the 10th goat sees the troll and troll has just 10 points, then maybe I don't know how many hit points has the. So if the number of hit points is smaller than lives, then these points will be subtracted from lives, but the goat will still alive. Will be alive. So bridge. So if we have some goats left, we will create a queue. And here parameters, max goats is the maximum number of goats. It also will be randomly generated between 3 and 5. The number of points of goats sorry, points of goats that can fit at the bridge at the same time. If the number of goats reached, if in other words, if the size of our queue reached this max goats number, then we will dequeue the first goat to the middle. And we will enqueue the next goat from our stack, from cover. But there is also max weight. If the total weight of the goats on the bridge is greater than max weight, then they will just fall from this bridge, unfortunately. Okay, so let's play this game. So the hit points of troll were generated randomly. It's 1400. And the hit points of one goat, as you remember, between 0 and 100. So how many goats do you want to initialize to hit to combat this troll? 27? Let's try 27. So the first goat was initialized with 152 hit points and pretty small weight. I wouldn't eat this goat for lunch. Well, troll. I don't know if troll eats the goats. He just fights the
shit out of
I don't eat. I just eat. So the second goat and so on. And so on 23 goats were initialized, and you can see how large is the difference between weights. Like if we have 3 goats of the weight with 300, that maybe it will overload our bridge. But if we have 1 goat with 300 and 2 goats with about 50, maybe it will be fine. Okay, so battle 1. Troll has this number of lives. So the first goat, he has this number of lives, but also every hit, every battle has a random number of damage that every person, or not person, every character can. Well, some persons are troll. Some persons are trolls, but definitely not all trolls are people. So in this case, our goat has 46 hit points to the troll, and troll does this amount of damage, so definitely it will kill our first goat, but troll will have smaller number of lives. Okay, so the battle continues, goes on, and as you can see, the index of goats begins from the largest one, because last input first died. Maybe we should change this name from life to life D was input first dead. Oh, last input was first dead. Okay, so and finally, I believe the number of goats is pretty large, so we should beat the troll. So okay, the goat 6 just 6 goats left from 32, or what was the number? Okay, let's continue. Okay, a lot again, a long story. So stage 2, the capacity of bridge was initialized randomly. It's about 900, and also the maximum number of goats, or the length of our queue, is 4 now. So goat 6 steps on the bridge, goat 5 steps on the bridge, and the total weight of the goats is 353. Goat 4 and goat 3. So after goat 3 steps the bridge, we reach the capacity. So the first goat will be queued to the middle, and we didn't separate the what is called the bridge, like strength. We have 2 capacities, like the length and also the maximum load of the bridge. So goat 6 crosses the bridge, and goat 2 enters the bridge. So the total weight is again smaller, and so on. All the goats cross the bridge. So do you want to try one more time and to see when the bridge is collapsed?
Sure.
So what number of goats we will use?
438.
400? Oh, so it will be a little bit hard to scroll all this history. Maybe. So the problem here is this random bridge capacity. If it's generated pretty high, that most likely all the goats will pass the bridge. If this random capacity of the bridge will be low, then most likely it will collapse just so. Yeah.
And it also depends on like how many goats are on at one time.
Yes, and also the randomly generated weight of each goat. So let's do maybe smaller, maybe 50 or 40 or 32. I mean, it depends on just random numbers, but it will be easier to scroll this text. So here it is. 40. I initialized 40 goats, and 10 goats survived. Okay, all goats passed the bridge. Let's run again. Let's try maybe 50. 21 goats survived. Oh. Oh, 0 goats survived. Okay, it's interesting. So 21 goat survived after the battle with Troll. Then the breach capacity is 885. Oh, this is why they collapsed, because the total number of goats is 5 now. The capacity of the goats on the bridge is 5. So the first, the second, the third, the fourth, and just after 4 goats on the bridge, it collapsed. So, Adam, you like when goats are dead? Yeah. So 4 goats on the bridge, they just fall from the bridge, and all the rest goats didn't make it to the meadow. This is the end of the fairy tale. So, okay. I also prepared, so I think we're done with queues and stacks, but I prepared one presentation on the packing and unpacking. So let's just, I just want to show you these slides. So, Python has a built-in function min, which returns the minimum value. So I created min with underscore. But what if we want to calculate the mean of more than 2 numbers? And moreover, what if we just don't know the number of numbers? So, for example, I want to calculate mean of 3 numbers, of 5 numbers. So in this case, we can use yes.
Is it min and max function in Python?
So min without underscore is a built-in
Yeah.
max, yes. But here I want to write our own function, which takes arbitrary number of inputs. So in this case, we can use this syntax asterisk and variable. If I print this input numbers will be stored in a tuple. So this is called packing. And then in my function, I can just go through this list, through this tuple of numbers and find the minimal value. So is it useful? Maybe. So what if you don't want to apply your function to empty input? Then you can pack only numbers beginning from the second one. So you can separate the first number and all other inputs you can pack into this array args. You can create another name, but it's the conventional name args. And yeah, then if you call your function from empty list, because it expects at least one input, will give you an error. Unpacking. You can write this code like asterisk of list or tuple or of a set, but the set there is a problem that after unpacking it can change the order. It will return these values separated by comma, and for example here, if I print unpacked range, so you remember range returns numbers 0, 1, 2. After unpacking, it will return this line and will print these numbers separated by empty space. So the result of print is 0, 1, 2, the same as you just write print of 0, comma, 1, comma, 2. Isn't this useful? So do you remember the last lab when you created the class, data class with information about the music? You could read this information into a list, like list with bitrate, duration, author, and so on, and then use new element, or what was the name for this, like son with capital S, and asterisk of this list instead of writing every element using commas. Yeah, so I think you appreciate this syntax. So this is not actually part of our class, but I thought that it's really useful, and you will see often this syntax in Python with asterisks. So also we have the default values. So default values are called keyword arguments. And you can also pack default values, default variables. So, but before we are moving forward, so here, for example, I want to find the minimum of numbers, but only if these numbers are greater than a given number, which I denoted by low and initialized by negative infinity. So, for example, here, 5, 3, 2, and the threshold is 2.1, so the minimum will be 3, because number 2 won't count. So why did I use float instead of int? I mean, if you write int of negative infinity, it will be also correct. Any guesses why we use float of int, but if you use int of inf, it won't make much sense. Do you remember about this, the memory for integers and for floats in Python? Integers are unlimited. So we actually don't know the maximum size. But floats, they have 64. And then you can pack the keyword arguments or the default parameters with two asterisks. Again, you can use arbitrary name, but the conventional name is keyword arguments. And if you print this, so for example, here, my keyword is low, you can write as many default parameters as you wish, low, high, and so on. Then, when you print this, they will be stored in a dictionary, like parameter name and parameter value. And then you can use these values inside your function. So this is taking off the keyword arguments. One comment: when we want to initialize the default value as list or tuple or set, and then I add this defaults will print the value of default values. So in the beginning, default value will be empty set. But if I change this variable inside my function and call my function again, the value of default variable will be changed. I mean, it's something unexpected. If you call your function twice and you did something with your default variable, it will be changed. But it works only for lists because lists are pointers to the memory. So if you use integers as your default values, it will be fine because default values are initialized only at first call of your function. And if you initialize an integer, it's fine. But if you initialize a list and change this list, then the original list also will be changed. So avoid this, you can just initialize by none, and then if your variable is none, set this to empty set, for example. And as you remember, none is falsy value. It means that if it's false, or will read the next next value. So it's the same as to write this assignment. And finally, you can do something more complicated, like you can separate the first and the last element, and then it will pack on the elements in between. Okay, so let's take a quiz, and that's it. Okay. No. Recording.